Okay, we're still doing the rules for divisibility, and in this section we'll discuss divisibility by pseudo division. It's a division without really doing a division. We are not interested in finding a quotient, we are interested in finding a remainder. So it's video number 6, part 2 of 3, and let's watch and see how we do that. Okay, continue. Let's continue. All right, let's continue here. Now we'll go to next section here where we would discuss divisibility by pseudo division. Let's see what that is. Pseudo division. To determine divisibility, we need to a remainder and see if that is 0. Okay, so in we're trying to find a remainder somehow. Okay, we will try to find a remainder here and see if that is 0. Let's continue here. One way to find the remainder is by dividing, and that is what we are trying to avoid. We really don't want to divide. Okay, to achieve that without really dividing is pseudo division. Okay, please have the patience and we will see what it is all together. Okay, together we'll see what it is. Okay, hint, we would ignore the quotient and continually attack the dividend to take away multiples of the divisor. Okay? So here is what we do. We would ignore the quotient. That's we don't care about because we are interested in the remainder. And continually attack the dividend. Dividend is the one we divide, okay, to take away the. Check out the pseudo division and using an example, okay. So where example is 780293331 divisible by 13. So we'll try to determine if a number is divisible by 13. Let's continue here. Okay, here's my cheat sheet. I wrote down multiples of 13 here, and you need to remember some of the multiples, and you don't need to remember all of those. And this is just I would need that to show you what I'm doing. Okay, so I wrote down the multiples, and you would have to remember some of the multiples here. Okay, maybe not all of them, but you should remember first 4 or 5. Okay, let's continue here. The original number is 780293331. I just added some spaces here so that I can work with it. Okay, let's continue. Identify sequence in the given number from which we can subtract multiples of 13. Okay, let's continue here. First, there's 78 here. I can subtract 78 6 times 13 to leave 0 there. Okay, next, the sequence 29. I can subtract 13 twice. So we can subtract 26 to leave a 3 there. In 29, we will have a 0, 9, 0, 3 here. Okay, let's continue. From 33 next. From 33, we can subtract 26 to leave 7. Let's continue, see what happens. Okay. So after we did that, 78 became zeros, and 29 became 0, 3, and 3, 3 became. Continue with the example we have. We will try to divide the number by 13. Let's see. Here's my cheat sheet. Here's the problem. Okay. And here's the original number, and here's the previous number. Okay. We started with the 780293331. After we knocked out some of the numbers here and we attacked the dividend, we were left with 73071 here. Okay. Let's continue here. Now we can subtract 26 from 30 here. Okay. So 30 would have 4 in the end. Okay, let's continue here. We can subtract 65. 65 is 5 times 13 from 71. That would leave 6. Let's continue here. That means now current number is 0, all zeros here, and 406. With example, here's my problem. Is this number 780293331 divisible by 13? Here's my cheat sheet, multiples of 13. This is original number 780293331. This is previous number. That's the number we ended up in on last slide. Okay, let's continue here. Subtract 30. I got 40 here. So we got 39 from 40 to leave 01. Okay, let's continue here. That would leave me 016. So I got 16 here. 16 is not divisible by 13. It's not in this list here. Okay, so neither is 780293331. Let's continue here. So 16 is not divisible by 13, and neither is 7802933. I have another example here. Example is 349349 divisible by 7? Here's my cheat sheet of multiples of 7 from the multiplication table. Let's continue. Here's the number. Original number is 349349. Okay. Now from here we'll attack this thing and take away or subtract multiples of 7. Let's continue here. So I take away from 34 28. So 28 is right here, 4 times 7. So leave a 0, 6. From 9, I take 7 away. That's 2. From 34, I take away 28, 0, 6. From this 9, I take away 7, become 2. Let's continue. Remove multiple 7 again. From 62, I take away 56. Leave a 0, 6. Then from 62 here, take away 0, 6 again. Okay, let's continue. Now we'll take away something from 60 here. Let's continue. So we take away from this 60 here, I take away 56. So leave away 0, 4. Okay, and 0, 6 still here. Let's continue here. Then from 40, I take away 35. Leave a 0, 5 here. So we have 56 left. 56 is in this table here. 56 is divisible by 7, and so is 349. 349. Let's continue. But 56 is divisible by 7, and so is 349. 349. Another example here. Example is 78029 divisible by 7. Here's my cheat sheet, multiples of 7. Okay, let's continue here. This is the number we have. Now we'll start attacking this number and subtracting multiples of 7 when we can. Let's continue here. So first, from 7 I subtract 7, becomes 0. From 8, take away 7, become 1. From 9, this is a 29 here. From 29, I take away 28, leave a 0, 1. Here's 33. I take away 28, leave 0, 5. And I leave the 1 here. Let's continue. Okay. Now, from 1, 0, 10, I take away 7, become a 3 here, 0, 3. From 10, I take away 7 again, become 0, 3. From 51, I remove, subtract 49. 49 is right here. Leave a 0, 2. Let's continue. From this 30, I take away 24. 7 times 4 is 28, becomes 0, 2 here. From this 30 again, we take away same 28 and 0, 2. So we go 3 zeros, 2, 2 zeros, 2 and 2. Let's continue here. From this 20 here, I take away 14, leave a 0, 6. From this 22 here, I'll take away 21, leave a 0, 1. Okay, let's continue now. Okay, from 60 here, I take away 56. 7 times 8. Leave a 0, 4, and then we got a 0, 4, 0, 1 here. Continue. Okay, from 40 here, I take away 35 to leave a 0, 5. So, okay, so now 51. We now left with 51 here. 51 is not in this list here. 49 is, 56 is, 51 is not. 51 is not divisible by 7, and neither is the original number, which is 780293331. Neither is 780293331. Another example, example 4. Example is 100000001 divisible by 17. Here's my cheat sheet of multiples: 17, 34, 51, 68, and so on. Let's continue here. This is the original number 1 followed by 7 zeros and a 1. Let's continue here. So first we remove the multiples of 17. So we take the first 100 here, 100, and remove 85 from here. 17 times 5 is 85. So 100 minus 75 is 015, and rest of them we continue 001. Okay, means 1 at the end and some zeros here. Let's continue. Now we got 150 here. From 150, I'm going to subtract 136. 17 times 8. Okay, we leave 14 here. Let's continue here. So now I got 140 here. Okay, from 140, I'm going to remove 136. Leave a 004. Okay, let's continue here. Then from 40, I take away 34. Leave a 06 here. Okay, let's continue here. Now I got 60. I got 60 here. From 60, I take away 51. Leave a 09. Okay, let's continue. From 90, I take away 85 from here. Leave a 05 here. And 51 is in this table here. 51 is divisible by 17, and so is 1 followed by 7 zeros and 1. Okay, let's continue here. Okay. And 51 is divisible by 17, and so is 1, 0, 0, 0, 0, 0, 0, 0, 1 is. Another example here. Is 34108735 divisible by 23? And here's my cheat sheet. Multiples of 23, 23, 46, 69, 92, 115, and so on. Let's continue here. Here's the original number, 34108735. So we'll start taking away multiples of 23. From 34, I can take away 23. Okay, let's see what happens. So from 34, I take away 23, get 11 here. Okay, now it's a 10, 10 and 8, 108. I can take away 92, leave a 16 here. From 73, I can take away 69, leave a 04 here. A 5 stays. Okay, let's continue here. We do same thing, remove multiples of 23. From 110, I remove out 92, leave a 0, 18. From 160, I take away 138 to leave a 022. From 45, I take away 23, leave a 22 here. Okay? Let's continue. Now I got 180 here. From 180, I take away 161. Leave a 019. From 222, from 222, I take away 207, leave a 15 here. Then 2 stays here. Let's continue here. From 190, I take away 184, leave a 6 here. From 152, I take away 138, leave a 14 here. Okay, let's continue here. Okay, from 60, I take away 46, leave 14 here. Then 14 still here. Okay, let's continue here. From 141, I take away 141, I take away 138, so leave a 3 here. So I got 34 in the end. Okay, let's continue here. So 34 is not in this list here. 23 is, 46 is, 34 is not. So 34 is not divisible by 23, and neither is the original number 34108735. 34108735. So this number is not divisible. Exercise here. Are the following numbers divisible by 7, 13, 17, 19, and 23? Let's continue here. Numbers are 7010044, next. 68670, next. 8847104, next. 4119670, next. 1643019, next. 6458128, and some more. Let's do summary here. This method is the most general method and is always applicable. Okay, it's similar to division without being a division, that it attacks the dividend to arrive at remainder. Okay, last number we got is a remainder. Okay, either a remainder or something we call altered remainder. Okay, so okay, let's continue here. It's not faster than division. We ignore the quotient and can attack the dividend at multiple places at the same time. Let's continue here. VM books do not seem to use this method. It's fast one and easy. In my opinion, it's fast and easy. Okay, it does not use any sutras though. Let's continue here. The main reference is our teacher's manual, and it does not have that oscillation method. Vedic mathematics by Bharati Tirtha Krishnaji have two methods of oscillation. Vedic math for schools have the by remainders method and does not have oscillation method. I didn't find it. Vedic math made easy by Bhatia doesn't have oscillation either. Vedic math for all ages has one method of oscillation. Okay, and here is the reference for if you wish to learn more about divisibility rule. This is the reference to go to. Okay? It has many more examples and methods mentioned.